This is Mrs. Naslund, and today we'll be looking at Unit 4, Lesson 6, Polygons. Our learning targets are: I can identify the attributes of and name regular and irregular polygons. I can construct a variety of polygons, including regular, irregular, convex, and concave. And I can find the perimeter of polygons. The vocab that we'll be discussing in this unit is polygon, closed, regular, irregular, congruent, convex, concave, triangle, quadrilateral, and pentagon. We'll cover all of these as we continue. All right, next we're going to look at some of the prefix poly, which means many, and the suffix gon, which refers to angles. A polygon has many different angles. A polygon has only straight line segments that do not cross each other. A polygon is closed. That means it has no endpoints. So we're going to look at these examples here and see if we can figure out which ones of these are polygons. So again, it can't cross itself and it can't have any openings. So if I look at A is a polygon because there's nothing that crosses and there's no openings. But B, nope, because it has openings in it. How about C? Yeah, C doesn't work because it has a cross. It crosses right here in the middle. How about D? No, because remember it has to have straight lines, and in D we have a curved line. So anything with D or with a curved line is not a polygon. E? E is a polygon. Even though it bends in, it has straight lines, nothing crosses, and there are no curved lines. How about F? Yep. F is a polygon as well. Again, straight lines, no openings, nothing crosses. G, what do you think? Polygon or not polygon? If you said polygon, you were correct. How about H? Nope, not H, because the lines cross. How about I? If you said no, you were correct, because it has an opening. You can't have an opening in a polygon. J is another example of a polygon. K is an example of a polygon as well. How about L? Yep, it's a polygon too. M is a polygon. N, no, just a single line does not make a polygon. O is a polygon, and so is P. All right, so now another question for you. Why must a polygon have 3 or more sides and angles? That's a great question. The answer is you have to have 3 more sides or angles. Oops, we're moving it all around. We have to have 3 more sides or angles because it must be closed, and a figure with only 2 sides and angles cannot be closed. All sides and angles of a regular polygon are congruent. Which of the polygons above look like they're regular? Okay, so we're trying to figure out the difference, trying to figure out what a regular polygon versus an irregular polygon. So the regular polygons, all of the sides in the polygon are congruent, meaning they're the same length. So if we look, which of our choices have ones that are the same length? Well, if we look at J, this side, I'll flip over my pen here, this side, this side, this side, and this side are all the same length. So I'm going to say J is congruent. Let's keep looking here. How about L? This side, and this side are all the same. They're all congruent, so L would be one as well. And what other shape? Look at the last row and see if you can figure out which other shape in the last row would be considered a regular polygon because all of the sides are congruent. If you said M, you were correct because all of these sides are equal to each other. So that makes it congruent. All right, let's keep going. Next, we'll be talking about convex and concave polygons. Polygons can be convex or concave. In a convex polygon, all of the diagonals are inside the polygon. In a concave polygon, at least one diagonal is on the outside. That sounds complicated, but it's not as complicated as it seems. So if I look at these different images here, convex means none of them are going in to the polygon. So number 4 is a convex polygon because it's not going in. But number 5, see how the polygon is going in there on the right hand side? So we're going to say that that is a concave polygon. Alright, take a look at number 6. What do you think? Convex or concave? If you said concave, you are correct because it dips in one section, it's concave. How about number 7? Convex or concave? If you said convex, you are correct. How can we remember the meaning of the word concave and convex? Well, one really easy way to remember is that if it dips in, like in example 5 here, and example 6, if it dips in like that, it's like a cave. It goes in, it tunnels in, so we know it's a concave polygon, and it's easy to remember that way. Can a concave polygon be a regular polygon? Great question. Well, remember our definition of a regular polygon was a polygon that all 3 sides were congruent to each other. They were all equal. So in this case, no, you can't have a concave polygon where all the sides are equal because you couldn't let it dip in and still have all the sides be equal. Can a triangle be concave? No, it can't, because remember, if it dipped in, then it wouldn't be a triangle anymore because you need all 3 sides in order to make that triangle. Alright, 2 more questions here and then we'll move on. What is a common name for a regular 4-sided polygon? So remember, it's regular, all the sides are equal, and it's 4-sided. What is the name of that shape? If you said square, you are correct. How about, what is a common name for a regular 3-sided polygon? Key word here being regular. Remember, regular means all the sides are congruent, so the triangle has 3 congruent sides. Ignore that little opening there. 3 congruent sides. What's the name of that triangle? If you said an equilateral triangle, you were correct. It would be an equilateral triangle. There we go. Let's move it up like that. Alright, good. Alright, on this slide we're going to be learning how to name polygons. Polygons have special names that tell how many sides and angles they have. Some names of polygons are triangles, quadrilaterals, and pentagon. So the first thing you need to know are the prefixes, the beginning of the words that match the number of sides and angles that the polygon has. So we think about 3. The prefix for 3 is tri. The prefix for 4 is quadra. The prefix for 5 is penta. For 6 is hexa. 7 is hepta. 8 is octa. 9 is nona. 10 is deca. And 12 is dodeca. These are tricky, and these are, the best thing to do with these is to try to memorize them so you know them. So now we're going to try to name all of these polygons. You'll use these prefixes up here to help you when we're trying to name it. So the first thing I do when I try to name polygons is I count all the sides. I just draw little lines to count 1, 2, 3, 4, 5, 6, 7, 8. Alright, this is an 8-sided polygon. So I look up here, number 18 here is an 8-sided polygon. So I'm going to call this one an octagon. Alright, next we have a 1, 2, 3, 4, 5-sided polygon. So I'm going to look up there, a 5-sided polygon is a penta. So I'm going to call it a pentagon. Alright, how about this next one here? Lots of sides. We've got 1, We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. A 12-sided polygon is called a dodecagon. How about a 3-sided polygon? I bet we know that one. That's a triangle. Alright, let's keep going. This one is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sided. A 10-sided polygon is called a decagon. Alright, we've got a 1, 2, 3, 4, 5, 6, 7-sided polygon. What would you call a 7-sided polygon? Think about it. What would it be? You said a heptagon. You were correct. Alright, we have a 1, 2, 3, 4, 5, 6-sided polygon. It's called a hexagon. A 4-sided polygon is called a square or a quadrilateral. And then last but not least, 30, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9-sided polygon. What is a 9-sided polygon? If you said a nonagon, you were correct. Alright, the last thing we'll be talking about is finding the perimeter of regular polygons. In this case, we have a group of regular polygons. So just like the perimeter for any other shape, we're going to take our one side and we're going to calculate how many it is. So this is a 4-sided shape and it's 6. So I'm going to say 6 times 4 is 24. And I've got 2 of these shapes. So I'm going to say 24 times 2. 4 times 2 is 8, 2 times 2 is 4. So the perimeter of the number 37 there of these two shapes is 48 centimeters. Alright, so now we'll go ahead and calculate the perimeter of this one. And I'll help get you set up, and then I want you to go ahead and finish calculating the perimeter. So if I take a look at this, we've got first some triangles with 3 sides. So we have 7 times 3, which gives us 21. And how many triangles do we have? 2. So I'm going to multiply that by 2. And then over here, we've got a 1, 2, 3, 4, 5-sided polygon times 5, which gives us 25. And I've got 2 of those as well. So I want you to go ahead and solve for this and see if you can figure out what you're going to do in order to find out the perimeter of all of those shapes combined. Alright, so if I was solving this, 2 times 1 is 2, 2 times 2 is 4, so I've got 42 inches, and then I have 50 inches, and then I'm going to want to add these two together, 50 plus 42. Actually rewrite it like this, it's a little easier. So I'd get 2, 5 plus 4 is 9. So my total perimeter of all 4 of these shapes is 92 inches. If you got 92 inches, congratulations. That concludes our lesson 4.6.